8.2 Arithmetic sequence and partial sums. What you should learn: recognize and write and find the nth term of an arithmetic sequence, find the nth partial sum of an arithmetic sequence, and use the arithmetic sequence in real life problems. So an arithmetic sequence is a sequence where each term is changing by the same number every single time. So we call that change a common difference. So for example, if I have a sequence of 3, 5, 7, 9, the common difference here would be 2. Because all we're doing is adding 2 every single time. That's an arithmetic sequence where it's the same number every single time. You just gotta add or subtract it. Here's some examples of arithmetic sequences. So 4n plus 3, if you see something like that, that's an arithmetic sequence. Right, the first term, plug in 1, you get 7, 11, 15, 9. So we're adding 4 every single time. You can't tell that by the number next to your slope. Arithmetic sequences are linear terms. So you have like your slope right there. So there's another arithmetic sequence. Look, so here we're going to keep on subtracting 5. So if you look at the numbers they plug in, first term, second term, third term, fourth term, they go down by 5 every single time. This is also an arithmetic sequence. It'd be an ugly one. It's a fraction. You multiply by 1/4, and you can go up by 1/4 every single time. So you can see that right there. Now, here's an example of not an arithmetic sequence. 1, 4, 9, 16. Right, it's like plus 3, plus 5, so that's not arithmetic. What they're doing, they're squaring each term. So remember, arithmetic has to be the exact same thing every single time. So this is going plus 1/4, this is going minus 5, this is going plus 4. So you have to add or subtract the same thing every single time to be arithmetic. And then if you look at like a general term, you could come up with you could derive the formula for it. So this is our formula for an arithmetic sequence right here. So let's talk about what everything does. A1 is the first term. D is a common difference, so you're adding, subtracting every single time. N is a term number. That's one you have to watch out for. It's not, so like over here, the third term is negative 8. So it's not negative 8, it's 3. That's what's going on there. So term number, what term number you are. And then AN is like the nth term. Now we're going to use this formula to write some equations. So look at the first one. Find a formula for the nth term of arithmetic sequence. So that right there means I'm going to use AN equals A1 plus N minus 1 times D, whose common difference is 3 and whose first term is 2. So they give us everything we need. Common difference is 3, first term is 2. So all I have to do is simplify this. 2 plus N minus 1 times 3, distribute. 2 plus 3N minus 3, add like terms. And you get 3N minus 1. So that's our arithmetic sequence. Now how about this one? The fourth term of arithmetic sequence is 20, and the 13th term is 65. Write the first several terms of the sequence. So big jump. So here's our arithmetic sequence. Now they're telling us here that the fourth term is 20. So they're saying A4 equals 20. So if you look at this formula here, when I plug in 4 for N, it's an equal 20. So 20 equals A1 plus 4 minus 1 times D. I forgot the D. Alright, so in this case, we're going to get 20 equals A1 plus 3D. That's as far as I can go with this one, right? So they're telling us that the fourth term is 20. They also tell us the 13th term is 65. So A13 equals 65. So same idea. When I plug in 13, I get 65. So 65 equals A1 plus 13 minus 1 times the common difference D. So this is 12. So 65 equals A1 plus 12D. So now we have two equations to unknowns. So we're going to solve it like we solve anything. We can do elimination, we can do substitution, any way we want. I'm going to do substitution because we could get A1 by itself. A1 equals 20 minus 3D. And we can plug that in to the other equation here. 65 equals A1 plus 12D. But we know A1 is 20 minus 3D. Out of like terms, right? So this is substitution. And this equation I solved for A1. I'm going to plug it into A1 on this equation. Now we can add up like terms, we get 65 equals 20 plus 9D, right? 3 minus 3D plus 12D, minus 20 minus 20. You get 45 equals 9D. Divide by 9. You get D equals 4. So that's my common difference. We just have to find our first term, but hey, we know d equals 4, so plug it in. And our first term is 20 minus 3 times 4, so 12. So a1 is 8. So we have a1 is 8. We know the common difference is 4. So we actually can find the next term pretty easily. a2 is just going to be 8 plus 4. It's a common difference, so 12. a3 is going to be 16. Just keep on adding 4. a4 is going to be 20. And so on. Right? Once you know the first term and the common difference, you can find the next terms very easily. Find the ninth term of arithmetic sequence whose first two terms are 2 and 9. So we're using the recursive formula here. So we know the first term is 2 and the second term is 9. Well, could it make it any easier? Right? What's my common difference? 7. So we could figure out what the rest are. So a3, So a3 is going to be 16, and we could keep on going until we get to a9 if we want, or we can just use a formula, right? an equals a1 plus n minus 1 times d, right? We know the first term is 2, and now we know the common difference is 7. So if I want the ninth term, a9, we just plug in 9 for n. 2 plus 9 minus 1 times 7, so this is 8 times 7. So 2 plus 56, which gets me 58. That's the ninth term. So you could keep on adding 7 until you get to the ninth term, or you could use our formula to help us out. It's about the sum of a finite arithmetic sequence. Remember, finite means it ends, so we're doing the sum of the first 5, the first 10, the first 200. As long as it ends, you use a finite sequence. This is a formula. There's actually 2 of them. There's this one, and there's also n over 2 times 2a1 plus n minus 1 times d. If you use this one right here, which looks more basic, but you have to make sure you have an. A lot of times people forget. They think it's just n. It's not. It's an. So you have to have that term. So if I want some of the first 10 terms, make sure this is the 10th term. This isn't 10, the 10th term. So this is an example here. Find the sum of this arithmetic sequence. So I guess technically you can just add them all up. Or we use our formula. Sn equals n over 2 a1 plus an. Now in this case, since I have the last term, it's actually much easier to use this formula. So a1 is 1. This is my an, so 19. But we also need how many terms. We actually have to count them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 terms. This was a10. Doesn't really do anything, just lets us know that's what that was. So 10 over 2 equals 1 plus 19. So this is 20. So you get 10 over 2 times 20. So 200 divided by 2 is 100. So that's how you find the sum of a finite arithmetic sequence. It works the same way here. So we want to find the partial sum of an arithmetic sequence. So I want to find only the first 150. So we could do Sn equals n over 2 times a1 plus an, or we could use the other formula, n over 2, 2a1 plus n minus 1 times d. Now, I'm going to do this one first. And this way you're looking at it like, hey, I know things. Right? My first term, 5, easy. I know I want 150 different terms, so right there. Problem is, you do not have this, because this is A150, but I don't know what A150 is right now. I could find it, not too bad to find it. You have to use our AN formula. Right? I'm looking for A150, so this is 150. A1 is 5. Our common difference, we have to look for it. It is 11. We're adding 11 every single time. So you could find it, but just keep that in mind. This is not 150. That's the most common mistake people make. Just plug 150 in here. No, it's not. It's a 150th term. So you have to find 150th term first. Once you do that, then you can plug it in. If you want, you can just use this formula. So this is where this formula is good, when you don't have the last term. So this formula is mostly the same, right? 150 over 2 times 2 times the first term, so 2 times 5, plus n, which is 150, minus 1 times the common difference, 11. So it's all like done all at once. So either way is fine. If you prefer this, go ahead and do this. Make sure you find the a term. You can use this other formula for find the sum of an arithmetic sequence, finite sum of an arithmetic sequence, and then sub it all in at once. And at the end, you should get 123,675. So that's the sum of the first 150 terms. We're adding all 150 terms, and we get over 1,023,675. Okay, one more. Application problem. So a small business sells $20,000 worth of sports memorabilia during its first year. The owner of the business has set a goal of increasing annual sales by $15K each year for the first 19 years. As soon as the goal is met, find the total sales during the first 20 years. So a couple things here. We have our first term, right? We have A1 equals 20K. We have our common difference. We want to increase by 15,000 each year. And we know we want to do it for the first 19 years, or 20 years. So N is 20. And we want the total sales. So we're looking for a sum. All right, so we're going to do another one where we do SN. S is for sum. We can either do this formula. Right, again, if I use this formula, I do have to find how much I sold in the 20th year. Or we can use this formula, which I don't need that. So we're going to use this one real quick. So my N is 20 over 2. A1 is 20,000 plus 20 years minus 1 times the common difference 15,000. And we get 3,250,000 like that. And that's the lesson.